center based on the usage of SBI Bank. But what happened when someone who is sitting in USA and trying to access the application which is getting hosted inside the data center which is in India? So that means the performance, latency, there are a lot of aspects which is going to be impacted when you are trying to access this application all across the globe, right? And what happened when what happened to when you have multiple data center and all goes through a disaster recovery scenario, and you are not able to access the data center which is there in India, then what happened to the the audience who are trying to access that particular application all over the world? So for disaster recovery also, it is a bigger challenges, and the most important is it is not DevOps capable. When we are talking about DevOps, that means it is a combination of cultural philosophies, which is a kind of practices and tools that increases the organization's ability to deliver the application at scale. That means when you are writing a web application, it is not like you have written a Java code or .NET code and you are done. You have to think beyond that, like how this code will be deployed inside a virtual machine or inside a app service or inside a public cloud area. So that's where the DevOps concept is coming. You have to have the development knowledge as well as the operational knowledge about the application infrastructure. So if you want to make it scalable and you want to your infrastructure should be highly scalable, then you have to think about the public cloud world, where this infrastructure will be accessible for you as a service. So the public cloud, what it says to the customer or to the vendors, guys, we will host the infrastructure for you. You can access this infrastructure all over the world via service. That is where the public cloud concept is coming. You do not have to take care of your data center. Rather than we will host the data center all across the world, and you access wherever you are sitting all over the world and get the benefits of public cloud. So it is much more reliable, disaster recoverable, and a lot of other aspects which you will get benefit when you are coming to public cloud. That is the basic difference between a private and public cloud. Now let's go to the next part. What is a private, public, as well as hybrid? So there are certain cases where, as it is public cloud, that means there are certain challenges when the organizations are going to public cloud. They want to keep their data in that particular territory that they do not want to expose outside world or, to the public cloud area where, others also can access it. That's where the hybrid cloud concepts are also coming, where you can host your data or you can keep your application, part of your application in private, part of your application in public, and you can realize a hybrid cloud concept where you can have both public cloud capabilities as well as private cloud capabilities. There are a lot of vendors which are available in market, like Microsoft Azure, AWS, Alibaba Cloud, Google Cloud. There are a lot of vendors which are available who are hosting the public cloud for you. Now let's try to understand the cloud deployment models. When we are talking about public cloud deployment models, there are three models which has been provided by public cloud vendors. One is IaaS, PaaS, and SaaS. So right now we are talking about public cloud world. So how to get your services or get your application running inside an infrastructure which has been developed by public cloud. Now this deployment model will tell you what are all different types of capabilities that this deployment model provide. When we are talking about IaaS, that means infrastructure as a service. That means you have your admin works also has to do. Just think about a virtual machine where you will run your application. Then in that case, you have to also patch your virtual machine to make it threat protection. You have to admin your virtual machine or scale up, scale down, disaster recovery. All these capabilities you have to do. When this type of need is coming, then IaaS capabilities is coming. And just above that, PaaS capabilities is coming, which is known as platform as a service. When we are talking about platform as a service, that means all these activities, the manual activities that we have talked as admin you have to do in IaaS, that is no need to be done in the PaaS layer. That means in PaaS layer, you will ask, okay, let Azure, can you give me a server which is capable of hosting your Java application in your platform. That means you will ask your need, and public cloud provider will provide you that infrastructure, and they will make sure the entire life cycle of that particular infrastructure will be taken care by them. That is the power of PaaS capabilities, and that's where we are going to talk about more today. And when you are talking about SaaS, that means software as a service. That means you will not think about your application as well. Rather than application infrastructure, everything will be provided by your public cloud vendor, and you just have to use that application layer. So in ES, you will have your admins who used to use it. PaaS is more towards the developers who wants to use the platform along with the developed code that they have built. And SaaS is more towards the end user who wants to realize that particular SaaS capabilities. You do not have to think about how to develop it. So these are all three capabilities which is mostly available by public cloud vendors: ES, PaaS, and SaaS. As we understood, so you as a developer, you have written a Java code and you have asked, okay, I have a Java code. Now I want to run that Java code in a Windows environment operating system. And the Java code has been written in a Spring framework and I want to host it in Microsoft Azure. So this is how you ask your need to the public cloud vendor, and public cloud will provide you the infrastructure where you can provision that. You do not have to think about how to provision the infrastructure, rather than they will provision it for you. That is what a PaaS capabilities is all about. Now, one of the famous PaaS capabilities is Azure App Service. When we are talking about Azure App Service, it enables you to build the host web apps, mobile backends, RESTful APIs in the programming language of your choice. That means you can write your .NET code, Java code, Ruby, Node.js. You just have to write it and you have to throw it to the Azure environment, and Azure App Service will make sure they will provision that particular piece of code that you are throwing at him, and it will be available, highly available all over the world if you enable that feature. We will talk about all these building blocks later. It also enables automated deployment from GitHub, Azure DevOps, and Git repository. When we are talking about automatic deployment, it is more towards continuous integration and continuous deployment. That means you want to scale your application at a high level so that you just have to write your code. You have to make sure the code, when you are committing the code to your repository, your infrastructure pipeline will spin up the infrastructure and deploy your code in that particular infrastructure the where you are throwing it. And also it supports both Windows and Linux OS. We will deep dive into it later. So the best benefit that you will get with Azure App Service is multiple languages and frameworks. As I said, you can write it .NET, Ruby, Java, Node.js. There are multiple languages which Azure App Services generally supports. DevOps optimization, that means it is highly integrated with DevOps tools like Azure DevOps, GitOps, and all, where you don't have to do much stuff, rather than the tools will do the stuff for you. Global scale with highly available, that means it is highly available all across the world. When we are talking about public cloud, they are divide the world into different regions. Inside different regions, you have different availability zones, and inside availability zones, you have different data centers. That's how it works. So all over the regions which has been provided by Microsoft Azure is supporting Azure App Services. So if you want to deploy, I'm sitting in Netherlands, I want to deploy my app service in USA region, that also can be done. That is the beauty of public cloud. It also supports containerization and Docker, and also it supports security and compliance. We will talk about all these building blocks later in the slide. Now let's talk about few architectural jargons. So there are five architectural best pillar, I can say, the Azure Microsoft Azure Well Architecture Framework supports. The 5 pillars are reliability, security, cost optimization, operational excellence, and performance efficiency. When we are talking about reliability aspect, that means the ability of a system to recover from a failure and continue to functions. That means you think about your application which is running, and during the run, there are a lot of users who are using your application, and your application is going down. Then the capabilities which has been provided by reliability engineering is to make your application up when your scaling is going high. That is the beauty of reliability. Security is nothing but a protecting application and data from threats. That means you have hosted your application, you want to make it much more protected. That means you have to think about the security aspect of that particular application. Cost optimization, you have to think, as public cloud works with the pay as a go service, where you will deploy your application in the public cloud services, and it has to make sure the cost that you are expecting should also in the control. Otherwise there is no usage of public cloud if you do not control the cost. Operational excellence is the process that keeps the system running in production. That means during the production environment, you should be also able to deploy or handle your application with your own credentials or with your own power or permissions. Performance efficiency, the ability of a system to adapt the change in load. That means when you have high load, that time how to handle that particular load with that particular request. So these are all 5 pillars of Microsoft Azure Well Architecture Framework that everybody has to go through when they are designing any web application, any application that they are implementing in public cloud. Now let's think about app service. So app service, just think about the scenario. You have written a Java code and you want to deploy it in app service. That means you have to think about how this app service will host that particular Java application. It at the end, if you think in a layman point of view, you need a hardware where you have to deploy your application, right? A server where you have to deploy your application and you have to host it. And to get that hardware, app service has a feature known as app service plan, which is nothing but, in a layman point of view, it is nothing but a piece of hardware where you will deploy or you will rely your app services in that particular hardware. So what exactly it needs? It needs an operating system. You can define what type of operating system that you want to define. That means Windows or Linux. Where you want to deploy that app service plan. As I said, like I'm sitting in Netherlands, I want to deploy it in West US or East US, then that also I have to define where exactly this hardware should be provisioned, in which area, in which region. Number of VM instances, that means how many instances where you want to deploy your app service, that also you have to define. Size of the VM instances, that means at the end it is a virtual machine behind the scene. Although it is a PaaS capabilities, it is trying to abstract the ES capabilities here. So you have to define like how many instances that you need. And also the most important part is the pricing tier. So when you are selecting the pricing tier, which could be free, shared, basic, standard. So based on the level of pricing tier, you have to pay more, but you will get a lot of benefit out of it. Just think about, isolated, or you think about premium V3. You want to make your app service zone redundant. That means when one zone is getting down, then another zone should be able to pick up your app service up and running. In that case, you have to use only premium V3. If you use the free tier app service plan and you want to enable that particular feature, to get that capabilities like load balancing and all, it will not support. So that's where you have to be very careful when you are defining or designing your app service plan. What exactly capabilities that you're looking for. Based on that, you can find which plan should be fit, should be a best fit for your design. And you will find a matrix also which has been provided with Microsoft Azure, which plan provides which features. Now we will talk about multi-tenancy versus single tenancy. So when we are talking about multi-tenancy, what does it mean? So when we are talking about public cloud, at the end, it is nothing but a data center which has been maintained by the cloud provider. It could be Microsoft Azure, or Amazon, or it could be Google. And when we are talking about data center, then there are multiple organizations also using that particular, data center. So when we are throwing out data or your application to that particular data center, then we have to be very, very careful what type of security that we need in that particular data center. Maybe that hardware is getting shared with other organization, like State Bank is using that particular hardware. At the same time, Axis also can use that particular hardware, right? So if you want to isolate your infrastructure in that particular data center or to the hardware level, then that concept is known as multi-tenancy and single tenancy. So if we are talking about app service single multi-tenancy, that means the hardware which is getting provisioned in that particular data center, it can be shared with other organization as well, other tenant as well. And in single tenancy, that means in that particular hardware, it is only dedicatedly reserved for you. That is the concept of single tenancy. So this is one of the building blocks that we are going to talk in app service. Next concept, we will also try to understand what is a inbound and outbound traffic. So when we are talking about app service, where you are deploying your app or your application, that means when any request is reaching to your app service, it is known as an inbound traffic. Please focus these points. We are going to correlate all these points when we are designing the final solution. So inbound is nothing but the request when it is reaching to your app service. Outbound is nothing but when a request is going outside your app service. Okay, this is the beauty of inbound and outbound concept. Now, Azure Cloud Connectivity Provisioning Area. That means, let's try to understand. This is the core concept of Microsoft Azure. In public cloud, you will find this is the concept everywhere. So in Azure, you will have always find there are two provisioning area. That means one is Azure Private, another is Azure Public. When we are talking about Azure Private, that means it is a logical boundary which has been completely restricted by you. No one else can reach it without your permission. That is the concept of Azure Private. In layman point of view, when you are thinking about a virtual network, when you are creating a virtual network which is restricted by a set of IPs where your application is getting provisioned, that means that particular virtual network is getting accessed by only you. No one else can access it. Whereas Azure Public is nothing but a public area of Microsoft Azure data center where that particular area can be shared by any other application or any other world as well, on any other organization. So that is the basic difference between a private and public region. Okay, so we will think when we are talking about app service, where exactly this app service will provision, whether it will be inside Azure public or inside Azure private. So let's go to the next slide. So inside multi-tenant web app, that means we are talking about a tenancy, a web app which is going to be provisioned in the data center or in a hardware which can be shared by other organization as well. So how we can make it much more secure? The first and foremost thing is when you are using a multi-tenant web app, that means it will be provisioned inside your Azure public area. So we have to make sure when we are provisioning a web app in Azure public, it should be only accessible by us. If it is much more secure enough, you want to build a security layer, that means we have to make sure it should be only accessed by us. And when the traffic is going outside the your web app, also it should be going to the exact destination where we want to. Okay, that's where your public and private is coming to picture. To reach this Azure public from your Azure private, you have two concepts. One is service endpoint, another is private link endpoint. That means in my organization, what I can do, I can provision a virtual network where I can define two subnets. That means it is nothing but a space where I am defining set of IP addresses. From there, I can define a service endpoint to reach this app service securely from your private to the Azure public area. And private link endpoint is nothing but when you want to reach this app service securely without going to the internet or within the boundary of Azure backbone network, that means I can use the private link endpoint. If I am not enabling this service endpoint and private link endpoint, that means my app service can be accessible by everyone. All over the world, people can access, and when they have the link and related data, they can access it. To restrict that, I have to always enable the service endpoint and private link endpoint. And when I want to control the outbound traffic from my app service, from my Java application, where I can reach the outbound connectivity, that can be only done via a app service delegated subnet. That means all the traffic forcefully will be routed to this subnet. From this subnet, I can define where exactly my traffic should go to. It could go to on-premise, it could go to internet, anywhere I want to control. I want to control that can be done by the delegated subnet. So this is the base concept. You have your inbound via the service endpoint, private link endpoint, and outbound via app service delegated subnet. Now let's talk about one more concept known as managed identity. When we are talking about managed identity, that means you have your app service which is getting provisioned inside your Azure public, and you are also connecting to a SQL database. So you have to store your data. In our 3-tower web application, we have the database as well, right? We provision the app service where we have provisioned the Java application or .NET application, and we want to store the data in the SQL database. That means when you want to access the SQL database, you have to have the SQL database URL. You have to have your username as well as the password. When you want to when you want to connect to this particular SQL database from your app service, you have to have the password. That means the password management is also coming to picture. The same time, Microsoft Azure has provided a very beautiful concept known as managed identity. That means it is a passwordless concept. So what it will do, it will create a user on behalf of you or on behalf of SQL database in Azure AD. That means it is inside Azure AD, it will create a particular user, and you can use that particular identity in your app service to reach this SQL database. You do not have to take care of the password. Rather than Azure will take care on behalf of you. So this is the beauty of managed identity. So you will go away from the passwordless connection. So that is also one of the best feature which has been provided by Microsoft Azure. There are two types of managed identity which is getting created when you are provisioning an app service or SQL database. One is service assigned managed identity, another is user assigned managed identity. So when we are talking about service assigned managed identity, that means it is completely tied up to the life cycle of that particular service. So when I'm provisioning a app service and a managed identity is getting created during that particular app service, that means it is service assigned managed identity. And when I'm deleting this app service, then the identity will also be deleted from your Azure AD. But when you're talking about user assigned managed identity, it is an independent identity which is getting created inside your Azure AD, and you can link that identity to the service where you want to latch this. So that is the concept of user assigned and service assigned. So when you are deleting that service, the user assigned will still be there. So if you want to connect from Azure App Service to the SQL database, you can use the managed identity. That means if we go via the concept, we want to reach this app service from our private via the service endpoint. From here, I am going to the delegated subnet via the private link endpoint. I will reach the SQL database, and I am using the managed identity to authenticate myself in the SQL database. So that's how you will enable a passwordless connectivity from your app service to your SQL database. App service also have another feature known as app service its own firewall. That means you can restrict certain IPs, like who can reach your app service when you want to make it private. That means you can whitelist those IP. Only those people or only those systems will be able to reach your app service. Even you also can whitelist your virtual network as well as subnet, so that you will restrict that from this virtual network and this subnet only your app service will be reachable. No one else, like as it is a multi-tenancy. So if you are from SBI Bank and you are hosting this app service and you are defining the SBI's virtual network IPs, then access cannot reach it. So that is how you can restrict the firewall with which where you can restrict only to your organization. So that's how you can restrict the reachability of that particular app service from a particular private network. So that's what about the connectivity and managed identity. Now let's think about another concept known as app service zone redundancy. When we are talking about app service zone redundancy, then let's think in that way. As we understood, Microsoft Azure has multiple regions, right? So when we are talking about region, that means it could be East US, it could be West US, it could be East Europe, West Europe, it could be India, any region where you want to deploy your application. How you can make your application highly available? To make it highly available inside a region, you have multiple availability zones, right? Inside your availability zones, you have multiple data centers which is getting provisioned. So when you are provisioning your app service, this is a new feature which has been published by App Service. I can say 6 or 8 months back they have enabled this feature. So previously, when you are provisioning your app service plan, it is always tied to that particular availability zone. It cannot be swapped across multiple availability zone. But if your availability zone is going down, then your application will die because you have not configured that application outside that particular zone. So to make it available, highly available within that region, there is a concept known as zone redundancy. That means when you enable that particular feature, it's nothing but a button inside the app service plan where you enable that particular feature. Okay, you want to enable the zone redundancy. Then what the public cloud will do, it will provision that particular app service across multiple regions, so that if your one region is going down, then the request will be routed to the second region or third region, whichever region which is available. So to make it available, when you are using app service, the minimum region which is needed is 3 regions that you have to enable. Within 3 regions, it will provision the app service zone redundancy, and after that it will swap based on the availability of that particular zone. To make your application highly reliable, disaster recoverable, you can always enable the zone redundancy feature inside your app service. Okay, so this is what about app service zone redundancy feature. Now let's try to think about our 3-layer architecture. Okay, so we have a front end, we have a back end, we have a database as well. How to interact app service with database via the managed identity. So these are all basic concepts that we understood. The one more concept that I have missed, I forgot to explain, is known as your load balancing. When you have your app service, you have multiple app services, you want to load balance the traffic across your app services. There you have to use a load balancer in your public cloud environment. So load balancer is nothing but in Azure, we have multiple load balancer like application gateway, internal load balancer, or Azure front door. So what I have decided here to use the application gateway. Why application gateway? Maybe I will explain. So when you are using application gateway, that means when your traffic is coming and you want to route the traffic to the load where exactly the application is getting hosted, then you can use application gateway. Application gateway comes with another beautiful feature known as WAP. Web application firewall. That means you want to make your application highly protected from the outside world via a set of rules. That means DDoS protection, all the protection. When an attacker attacks your application, you want to protect that threat protection model inside your web application. Then you can use application gateway. So it has an inbuilt WAF where you can use it to make it much more protected. It also SSL termination. That means when a request is coming and it is encrypted with that particular request, you want to do the SSL termination here. That means your SSL protection is getting terminated here. The certificate which is getting installed in this application gateway, it will terminate that particular protection, and then it will route the traffic to the respective backend based on the configuration that you are doing. So application gateway has a front end as well as a backend pool. So when you are talking about front end area, that means it's a listener, which is where you are defining who will reach your application gateway, and from there you will define where exactly the traffic will be routed. So application gateway, it is one of the subnet which will be there inside your virtual network. We are talking about a secure environment, so that's why I have given this example. So you will first and foremost thing that you have to do is provision a virtual network. Inside that virtual network, you have to have your application gateway subnet, and particular to that application gateway subnet, you have a private link subnet. So via the private link endpoint, you will reach your app services, which is in Azure public. So there are two regions, as you can see here. One is private, another is public. So private is nothing but your virtual network. So when a request is coming to your application gateway, it is going to the private link. From private link, it is reaching to your front end screen. That means your front end application, which is getting hosted here. From front end application, you want to go to your backend application, which is a separate app service plan. So if you go directly from here to here, then it is moving your traffic within your Azure public area. So to make it much more secure, what you can do, you can route your traffic from your front end to your delegated subnet. That means you're routing it to your on-premise system, your private network. And from the private network, you're routing it to your private link endpoint. And via private link endpoint, you're securely reaching to your backend. And from this backend, you can, again, you want to reach to your another PaaS services, which is a PostgreSQL database. That means whenever a PaaS service is coming to this, then you can reach that PaaS service securely from this private link endpoint. So again, from your backend, you will go to your delegated subnet. From your delegated subnet, you will reach your private link endpoint. From your private link endpoint, you will reach your database. That's how securely you have connected your application, which is a 3-tier application. That means it has a front end, it has a back end, it has a database via a virtual network. That means all the traffic is in your control. There could be another scenario. You want to reach or you want to call an API which is outside your Azure private area. That means it's an API which is outside your public cloud area. How to reach that? To reach that, what you can do when you are going outside the world of Azure or your public cloud, here from your delegated subnet, you want to make an API call. That means you can go via the Azure firewall. You can you install a particular subnet which will have the firewall instances, which is also another capabilities in Azure world. From the firewall, you can whitelist what is the source and destination. Here my source is delegated subnet and destination is the IP where I want to reach the API. So when the request is going via the firewall, only the whitelisted part will be reachable via the firewall. And no other application can reach, can move out. No other request can move out. So to control that, to reach outside world, you can use the Azure firewall capabilities. So that's how you can make a call to your outside world. And also, if you want to make a call to your on-premise system, that means we are talking about a hybrid cloud scenario, right? We have a public cloud here, which is a Azure region, and we have an on-premise system, which is our private cloud. So when you want to reach your private cloud, Azure has multiple capabilities like Express Route, VPN. So you can install that particular appliances in your private network, and from that private network securely, when you are using VPN, that means it is an encrypted request which is going to your on-premise system. So this is how you have a 360-degree view connectivity to your on-premise as well as your internet. So from your app, let's again repeat the flow. So when I am a user, I am trying to reach this front-end application. I will reach the application gateway URL. So that is latched with a particular DNS. and from that particular application gateway URL, I will reach to that private link. From the private link, I will reach to the front end screen, and the front end screen, I will go to the subnet, and then I will go to the backend screen. And from the backend application, I will reach to the SQL database or to the on-premise or to the internet. I will do the processing, whatever I wanted to do in the backend machine, and then after that, I will return the request to the front end, and then the front end will return the request to the via the application gateway to the user. So that's how a web application can be designed. Now, how I can make this web application highly available all across the world? To make the application highly available, we can think about active or active passive mode. That means you can have your first region. Let's think about this way. We have our first region, which is in East US or or West US, and the second region is in East US. That means when the region itself going down, that means the data center, the availability zone, whatever available in that particular region is has been died due to some disaster, then the request will be coming to the second region. That's how you can make your application highly available all across world by deploying into multiple regions. You can make it much more scalable or highly available via 2 OR method, that is known as active passive hot standby and cold standby. When we are talking about active passive hot standby, that means both the region you have your web apps which is running, and then you have your database which is also running, and database has a GRS capabilities, which is known as zone redundancy capabilities, where the data which is there in the first region will be synced to the second region automatically, and you do not have to do anything rather than the database will sync themselves, so that you will always find a identified data in both the cases. So it is all about hot standby. When we are talking about cold standby, that means you do not need to provision your application or app services in your second region. Rather than when there is a disaster which has happened to your first region, then it will automatically redirect to the second region, and it will provision everything, and it will sync the data. So that's how hot and cold standby works. And as we are talking about multiple regions, we cannot use application gateway, because application gateway is a zonal service, it's a regional service. That means it will be available inside that particular region. But we want to make it globally available, then we can think about outside globe, outside the region. There should be something which will route the traffic to the particular regions, right? So that's why Azure has another beautiful load balancer known as Azure Front Door. It also has web capabilities, but it is quite costly as compared to application gateway. So application from your Azure Front Door, you can route your traffic to multiple regions, and from your multiple regions, the flow is very straightforward. That means it will reach to your front end, and from the front end, it will go to the back end. And this microflow I have explained already in the previous slide. So via your network, you will reach your backend, and from your backend, you can reach your PLE enabled service. Your backend via the firewall, you can reach your internet. Via the VPN gateway, you can reach your on-premise system. So this is how you can make your application highly available in the Azure web era. One more thing also we can think about when we are talking about this type of solution, then it also comes with a lot of cost, because you are going to provision both the environment at a time. So you are going to provision both the environment at a time. That means as both the environment is running, so the cost will also be impacted. So as we will talk about, again, we'll go to the previous slide, where reliability engineering, security, cost optimization. So we talked about the security part. We talked about the cost estimate optimization part. So you have to be very careful when you are designing this solution. You have to be very sure what exactly the need is. If your application should be definitely available and you want to make it highly available or across the region, then you have to think about active passive, and again, it will be coming with the cost. As operational excellence, as it is a PaaS capabilities, it will make sure it is highly available all across the region. But there are cases where your region is getting failed, and you have to think about that. Performance efficiency, you have to, to increase the performance, you can think about the CDN kind of capabilities, where you can cache the data at your CDN level and then route it back to the user. And reliability is nothing but the disaster recovery. When there is a failure happens, then your application, the design, the way you should define it, it should be highly available to your application user. So that's how this 5 pillar can be realizable. And when we are talking about, again, if you think about this part, this web application, the application which we are talking about, when this server is getting maintained by your own data center, then you have to form a team who will make sure your servers will be running in your data center and your servers will be available. And in case of any disaster recovery, when your data center is going down, then you have to again run behind the vendors. The most biggest challenge that we have seen with the private cloud is it is not highly scalable. That means you have a separate team who used to take care of that particular data center. They have the knowledge of networking, they have the knowledge of hardware installation, and they take care of it. Whereas if you're thinking about public cloud, this server configuration part is getting taken care by the public cloud vendors, and you only have to focus on the concept, how to use that particular server concept to realize your application. That's where the public cloud is coming to picture. It is highly recommended, right? As it is a hotcake in the market, in the IT market. Everybody is going towards public cloud. So I would highly recommend, go ahead with certification, increase your skills with public cloud. This is the best service to start with. Even a storage account is another service to start with your public cloud journey. If you are new to public cloud, just explore different aspects, the private public networking, and PaaS capabilities, EaaS capabilities, SaaS capabilities. It will definitely bring you a good amount of values for you in the market, and you will be find yourself a different candidate than others in this competitive market. So that's what I wanted to share as an experience, how to develop a web app in a, infrastructure designing with app services. That's what from my side. Any questions or anything that you want to talk, or maybe I will hand it over to Gavaskar in that case. Gavaskar, are you there? Let me go through few questions. So at the end of the day, it is cost effective. Yes, so it is definitely cost effective, because you will pay only the amount of the amount of users. Based on the users you have to pay. So you have to think about what exactly you are going to use, and based on that you have to pay. So it's all about your design, I can say. So the complex you are designing your solution, the more cost will be definitely impacted. But yeah, cost is also coming up with a lot of improvements and solutions. So use it based on your use. Yeah, Gavaskar, I can hear you now.
Okay. So one more question: can two Windows-based app service hosted include?
Where is the question?
Yeah. Can two Windows-based app service hosted in two different subnets? One question from audience. You can see that question.
Yeah, when we are talking about app service in a subnet, yes, we are not hosting a app service inside a subnet, as my diagram has clearly depicted. Your app service will always run inside a public network, and you have to route your traffic to your subnets, to your outbound traffic. So if you want to route your traffic to the particular subnet, then it should be one subnet. There is no need of using two subnets. Rather than, if you want to control the traffic flow, then you can configure the NSG changes and you can control that. But if you are going ahead with another subnet, then again another subnet will come up with a set of IPs, and private IPs cost a lot. So be careful when you are thinking about that aspect.
Any more questions from audience?
A lot of developers use or prefer AWS. What is the difference between all of these clouds? To be honest, guys, when I have tried to compare AWS, Azure, and Google Cloud, the basic concept is always the same. there is no change between the fundamental concept between the all these clouds. Only the naming conventions are different. So if you are finding let app service is in Azure world, then in AWS you will find elastic beanstalk, where you can provision the same capabilities. They have some pros and cons based on their uses. So based on your need, you can verify which cloud is suitable for you. But almost everywhere the concepts are always the same. Yes, concept are everywhere all the same. Yeah, I can say.
So participants, any more questions?
I think that's it in that case,
Yeah,
Gavaskar.
yeah. So I will share the screen and announce the speaker code. Okay.
Yep. Thank you.
So participants, moving to the key takeaways. Um, okay, this is a speaker code. Okay, you can provide the speaker code in the private dashboard by clicking claim certificate link. That is 61QUEBZ. It's a speaker code you have to provide for claiming the certificate. So once again, I will share this in the chart. So, so audience, again I will repeat the speaker code 61QEBZ. So participants, if you have any doubts, you can ask. So Neil, shall we conclude the session? Hello. Yeah.
Yeah, Gavaskar.
Yeah.
Yeah.
There. Okay. Okay, on behalf of Multicloud for You, we like to thank Neil for delivering an excellent session on Azure Web App Designing. And thank you once again on behalf of Multicloud for You. Thank you, Neil.
Yeah. Thank you, Gavaskar and Multi Cloud team. Thank you.
Okay, thank you. Thank you.